Hello everyone and welcome back. I am Mr. Cobalt and today we're going to go over polyatomic ions. I'm going to discuss what the polyatomic ions are, and I'm also going to introduce you to a lot of them. This is not all of them. This is a large amount, but it's definitely not all. And what I'm going to do in this video is I'm going to show you ways in which you can see patterns that will help you to memorize the formula as well as memorize the charges on the ions. If you can remember the patterns, then that will go a long way to help you remember what the polyatomic ion is, what the formula is, and what the charge is, because that's going to be very important for when you are asked to write down the formula of a compound that involves the polyatomic ions. Or the name of a compound that has the polyatomic ions, because if you don't know the formula or if you don't know the charge, it's going to be really difficult to do that. Okay, so what I have here on the board is a list of many of the common polyatomic ions. And so what I want to do is I want to go over the names a little bit and show you some things about the names that should stand out to you. So one of the things you'll notice is that a lot of them end in ATE. So you have acetate, carbonate, hydrogen carbonate. Some of them have IDE endings. Some of them end in ITE, ite, and so on. And so if you look at the different ones, you can maybe see a pattern. But one of the things I want to point out first is that each ion has its own name. You don't need to drop anything. You don't need to change the ending to IDE or anything like that. The name of the ion is as it is written on the board. So you just need to know the name that is written here. So this ion is called the hydroxide ion. This ion here is called the hydrogen carbonate ion, or the bicarbonate ion is also another name for it. This one is called the hypochlorite ion. So you don't need to change anything about the name. The name stays the way it is. You just need to remember what the name is. Okay. So one of the things I want to point out is you'll notice that some end in ITE and some end in ATE. And then they have similar formulas as well. So, but some of them are standalone names, right? They're not related to anything. Like, so there's no pattern, if you will, that is associated with those. So, for example, acetate. This is the formula for acetate: C2H3O2 minus, and it has a minus charge. You just need to memorize that. There's no way around remembering that other than just memorizing it. Carbonate 2, CO3 2 minus. That's going to be one where you're just going to need to remember what the carbonate ion is. So what are some of these patterns? I mentioned ite and ate. So ITE ending and ATE ending. So you look at these two here. So these two formulas, you have nitrite and you have NO2 minus and nitrate NO3 minus. Okay, here you have ite and ate. So you have phosphite and phosphate. Phosphate has PO3 3 minus, and phosphate has PO4 3 minus. So what pattern do you notice? Well, if you notice that the phosphates, or anything that what ends in ate, right? So this has an 8 ending, and this has an 8 ending here, nitrate and phosphate. You'll notice that if we're comparing the two formulas between phosphate and phosphite, the formula that has more oxygens has the AT ending, right? So PO4 3 minus, this has one more oxygen than the phosphite, PO3 minus, or 3 3 minus. that is going to have the AT ending. So you can remember that the difference between phosphate and phosphite is the difference between one oxygen. The 8 is going to have one more oxygen than the ite. So if you can remember one, then you can remember the other. So if I remember that phosphite is PO3, 3 minus, then I can remember that the 8 has one more oxygen, so it's PO4, 3 minus. And they both have the same charges, same amount of charge, so they both have 3 minus. Nitrate and nitrite, same thing going on here. So you have NO2 minus and NO3 minus. The one that has NO3, one more oxygen, is going to have the AT ending. So this is NO3 minus, that's going to be your nitrate, and this has one less oxygen, that's going to be your nitrite. So again, if you can remember one, then you can remember the other because of the pattern. And they both have a -1 charge. So everything's the same about these two polyatomic ions, except one has one more oxygen than the other. So that's one pattern. You can see other patterns as well. So here, again, I have sulfite and sulfate. So they both have SO, both have sulfur and oxygen, The sulfate has 3O4, 2 minus. The sulfite has 3O4, 2 minus. And so you could see that as well. And there's also, you could also see phosphate and phosphite are the same formula, except that sulfate and sulfite have a sulfur instead of a phosphorus. And the sulfate and sulfite have a 2 minus charge instead of a 3 minus charge. So the pattern of 8 and ite is consistent with this as well. Okay, so sulfite, sulfate. Sulfate will have one more oxygen, SO4, 2 minus, and sulfate will have one less. And if you can remember phosphate and phosphite, and you can remember, well, okay, sulfate and sulfite is pretty much the same formula, except you have sulfur instead of phosphorus, and you have one less charge. You have a -2 instead of a -3. That can help you remember the different ions. Okay. So that's one thing. I want to continue also with, sometimes you're going to have 4 polyatomic ions that look very similar, and the only difference is that you have one or more one or more oxygens. So if you notice here, this is chlorite and chlorate. So the difference between chlorite and chlorate is going to be that one has one more oxygen than the other. So the chlorate should have one more oxygen. So the chlorite is ClO2 minus. Chlorate should have one more oxygen, ClO3 minus. So if you can remember what chlorite is, then you just add, if you know what chlorite is, you just add one more oxygen, and that's your chlorate. Okay, and you can see that these two are pretty much the same formula as NO2, NO3, so nitrite, except instead of having nitrogen, you have chlorine, right? So you can see patterns that will help you remember. However, if you have 4, look, we have 4 of these that are very similar. They all have chlorine and oxygen. They all have a -1 charge, but the difference is the number of oxygens. So we just said that the 2 middle ones are chlorite, chlorate, and so chlorite has 2 oxygens, chlorate has 3 oxygens. Well, what about this one? Well, if you add another oxygen to it, then we keep the same ending, 8, but then we add a prefix called per. So you can think of per as in being thoroughly oxygenated, like lots of oxygen. So perchlorate is going to have another oxygen on top of chlorate. So you get ClO4 instead of ClO3. What about this hypochlorite. Notice that this one has ClO minus, so it has one less oxygen than your chlorite. So you're going to keep the ite ending, but then you add the prefix hypo. So you could think of hypo as being like much less oxygen, right? Hypo meaning below, like hypothermia, right? You're losing heat. You're below the heat that you should have, right? So hypochlorite means even less oxygen, so it's going to be one less oxygen than the hypochlorite. So you can remember this pattern and remember the two middle ones. So the one with 3 oxygens is going to be chlorate, one less oxygen, chlorite. One more oxygen than this one, it's perchlorate. One less oxygen, this one, it's hypochlorite. So that's a pattern as well. And this works with other things as well. You could have, notice that this is a chlorine atom, which is a halogen. You can replace that with other halogens and get other polyatomic ions, right? So for example, I could change the chlorine to a bromine, and I'd get BrO minus, or BrO2 minus, or BrO3 minus, or BrO4 minus, right? So then if you wanted to figure out the names of these, if you wanted to figure out the names of these, then instead of chlorite, you just say bromite. So this would be bromite, this would be bromate, this would be hypobromite, this would be perbromate, right? So you could do this with iodine, you could switch out with other halogens as well. So the pattern would fit with those as well. Okay, so also the other thing is I want to point out you have sulfite and hydrogen sulfite, and the difference between these is the hydrogen. So if you add a hydrogen, then you get hydrogen sulfite. If you add a hydrogen to sulfate, then you get hydrogen sulfate, or also bisulfate or bisulfite are other names you could do as well. Okay, now the other pattern I want to point out quickly before the end of this video is that you can also use patterns with regard to the charges. You can remember the charges, for example. So if notice if phosphite and phosphate have phosphorus in them. Well, if you remember the charge of phosphorus from your periodic table, if you remember the rule, right? So if you're in group 5, it's the group number -8, that gives you a -3 for phosphorus. Well, look at the charge on phosphate and phosphite. It's -3. So if you can remember the charge on phosphorus, you can remember the charge on the phosphate and phosphite. Same thing with sulfite and sulfate, right? Sulfur is in group 6. Group 6 -8 gives you -2, so the charge on sulfur is -2. Sulfite and sulfate have sulfur in them, and then that is also a -2. So that you could use that to remember. Also, another one is with your chlorite and chlorates, right? They all have -1. Well, chlorine is in group 7. 7 -8 is -1. So if you can remember the charge on the chloride ion, you can remember the charge on the chlorite ions here. Now, this doesn't work all the time, so you can see on nitrate, they have a -1 charge, but nitrogen has a -3 charge, so it's not, there are exceptions, but it is a rule of thumb that is useful to help you remember. Now, one more thing I want to point out really quickly. Notice that I have carbonate here, which is a -2 charge. Now, if I add a hydrogen, hydrogen tends to be a +1 charge. So if I add a hydrogen to it, then the plus will cancel out one of the negatives and you get a -1. So that can help you remember what the charge is on these. So if you go from CO3 to HCO3, you drop down by 1. If you go from phosphate, which is 3 negative, to HPO4, you go to a 2 negative. Or if you have two hydrogens, it's one negative. So you could use that as well.